Hi, everybody. My name is Iqbal Khan, and I am a technology evangelist at Alachisoft. Alachisoft is a software company based in San Francisco Bay Area and is the maker of the popular Encache product, which is an open source distributed cache for .NET. Alachisoft is also the maker of NosDB, which is an open source NoSQL database for .NET. Today I'm going to talk about 6 reasons why Encache is better than Redis for .NET applications. Redis, as you know, is developed by Redis Labs, and it was picked by Microsoft for Azure. The main reason for picking was that Redis offers multi-platform support and lots of different languages, whereas Encache is purely focused on .NET. So let's get started. Before I go into the comparisons, let me first give you a brief introduction of what distributed caching is, and why do you need it, and what problem does it solve. Distributed caching is actually used to help improve your application's scalability. As you know, if you have a web application or web services application or any server application, you can add more servers at the application tier. Usually the application architectures allow that to be done very seamlessly. But you cannot do the same at the database tier, especially if you're using a relational database or a legacy mainframe data. You can do that for NoSQL, but in majority of the cases, you have to use relational databases for both technical and business reasons. So you have to solve this scalability bottleneck that relational databases or legacy mainframe give you through distributed caching. And the way you do that is by creating a caching tier in between the application tier and the database. This caching tier consists of 2 or more servers. These are usually low-cost servers. In case of Encache, the typical configuration is a dual CPU quad-core machine with 16 to 32 gig of RAM and 1 to 2 network cards, which are 1 to 10 gigabits in speed. And these caching servers form a TCP-based cluster in case of Encache, and they pool the resources of all these servers together into one logical capacity. That way, as you grow the application tier, let's say if you have more and more traffic or more transaction load, you can add more servers at the application tier. You can also add more servers at the caching tier. Usually you maintain a 4:1 or a 5:1 ratio between the application tier and the caching tier. So because of this, the distributed cache never becomes a bottleneck. And so you can start to cache application data here and reduce traffic to the database. The goal is to have about 80% of your traffic go to the cache, and about 20% of the traffic, which is usually your updates, go to the database. And if you do that, then your application never faces a scalability bottleneck. Okay, so keeping that benefit of a distributed caching in mind, let's talk about the different use cases that the different situations in which you can use a distributed cache. Number one is the application data caching, which is the same as what I just explained, where you cache data that resides in your database so that you can improve performance and scalability. The main thing to keep in mind for an application data caching is that your data now exists in 2 places. It exists in your database, which is the master data source, and it exists also in the caching tier. And when that happens, the most important thing that you need to keep in mind is that the biggest worry that comes is the cache going to become stale? Is the cache going to have an older version of the data, even though the data has changed in the database? If that situation occurs, then of course you have a big problem. And many people, because of this fear of data integrity problems, they only cache read-only data. Well, the read-only data is a very small subset of the total data that you should be caching, and it's about 10 to 15% of the data. The real benefit lies if you can start to cache transactional data. This is your customers, your activities, your history, all sorts of the data that gets created at runtime, and it changes very frequently. You need to still cache that data, but you need to cache it in a way that the cache always stays fresh. So that's the first use case, and we'll come back to that. The second use case is for ASP.NET specific caching, where you cache the session state, the view state, and if you don't have the MVC framework, and the page output. In this situation, you're caching the session state because a cache is a much faster and more scalable store than your database, which is where you would otherwise be caching the sessions or the other options that Microsoft gives you. And in this case, the data is transient. Transient means it's temporary in nature. It is only needed for a small period of time, after which you'll just throw it away. And the data only exists in the cache. So the cache is the master store. So in this use case, the worry is not that the cache needs to be synchronized with the database, but instead the worry is that if any cache server goes down, you lose some of the data because it's all in-memory storage, and memory, as you know, is volatile. So a good distributed cache must provide intelligent replication strategies so that you have every piece of data exist in more than one server. So if any one server goes down, you don't lose any data. But the replication has cost associated, performance costs, so the replication must be super fast, which is what Encache does, by the way. The third use case is a runtime data sharing use case where you use the cache as essentially a data sharing platform. So a lot of different applications are connected to the cache, and they can do share data in a pub-sub model. So one application produces the data, puts it in the cache, fires an event, and other applications that have registered interest in that event will be notified, so they can go and consume that data. So there are also other events. There are key-based events, there are cache-level events. There's a continuous query feature that Encache has. So there are a number of ways that you can use a distributed cache like Encache to share data among different applications. In this case also, even though the data is created from data in the database, but the form in which it is being shared may only exist in the cache. So you must make sure that the cache replicates data. So the concern is the same as for ASP.NET caching. So those are the three use cases that are common for a distributed cache. Please keep these use cases in mind as I compare the features that Encache provides, which Redis does not. So the first reason why you should use Encache over Redis is that Encache provides you very powerful features to keep the cache fresh. As we talked about this, if you cannot keep the cache fresh, you are forced to cache read-only data. And if you're caching read-only data, then that's not the real benefit. So you need to be able to cache pretty much all your data, even data that is changing every 10-15 seconds. So the first way that you keep the cache fresh is through expirations. Expirations is something that both Encache and Redis provide. So for example, there's an absolute expiration where you tell the cache, please expire this data after 10 minutes or 2 minutes or 1 minute. After that time, the cache removes that data from the cache, and you're making a guess. You're saying, I think it's safe to keep this data in the cache for this long because I don't think it's going to change in the database. So based on that guess, you're telling the cache to expire the data. Here's how expiration looks like. I'm just going to show you something. In case of Encache, when you install Encache, by the way, it gives you a bunch of samples. So one of the samples is called Basic Operations, which I have it opened here. So in Basic Operations, let me just quickly also give you, here's what a typical .NET application using Encache looks like. You link with the encache.runtime and encache.web assembly, then you use the encache.runtime namespace and encache.web.caching namespace, and then at the beginning of your application, you connect with the cache. All caches are named. If you want to know how to create a cache, please watch our Getting Started video that's available on our website. But let's say that you've connected to this cache, so you get a cache handle. Now you create your data, which is some bunch of objects, and then you do cache.add. Cache.add has a key, which is a string, and the actual value, which is your object. And then in this case, you're specifying an absolute expiration of 1 minute. So you're saying expire this object 1 minute from now. And by saying that, you're telling Encache to expire this object. So that's how expiration works, which of course, as I said, Redis also provides you. But the problem with expiration is you're making a guess which may not be correct, may not be accurate. So what if the data changes before that 1 minute or before that 5 minute that you had specified? So that's where you need this other feature called synchronize the cache with the database. This is a feature that Encache has and Redis does not have. So Encache does it in a number of ways. The number first is SQL dependency. SQL dependency is a feature of SQL Server through ADO.NET, where you basically specify a SQL statement, and you tell SQL Server and say, please monitor this data set. And if this data set changes, that means any row is added, updated, or deleted that matches this data set criteria, please notify me. So the database sends you a database notification, and then you can take appropriate action. So the way Encache does this is Encache will use the SQL dependency, and there's also an Oracle dependency which does the same thing with Oracle. They both work with database events. So Encache will use the SQL dependency. Let me show you that code here. So I'm just going to go to the SQL dependency code. Again, same way you link with some of the assemblies. You get the cache handle, and now that you're adding stuff, I'm just going to go to this, go to definition. So now that you're adding this data, as part of the adding, you specify a SQL dependency. So Encache SQL cache dependency is an Encache class that takes a connection string to your database, and it takes a SQL statement. So let's say in this case you're saying I want the SQL statement is where the product ID is this ID. So since you're caching a product object, you're matching it with the corresponding row in the product table. So you're telling Encache to talk to SQL Server and use SQL dependency so that SQL Server can monitor this statement. And if this data changes, SQL Server notifies Encache. So now the cache server has become a client of your database. So the cache server has asked your SQL Server to please notify me if this data set changes. And when that data set changes, SQL Server notifies the cache server, and the Encache server then removes that item from the cache. And the reason it removes it is because once it's removed, the next time you need it, you will not find it in the cache, and you'll be forced to get it from the database. So that's how you kind of refresh it. There's another way that you can automatically reload the item that I'll talk about in a bit. So SQL dependency allows Encache to really synchronize the cache with the database. And with Oracle dependency, it works exactly the same way, except it works with Oracle instead of SQL Server. SQL dependency is really powerful, but it's also chatty. So let's say if you have 10,000 items or 100,000 items, you're going to create 100,000 SQL dependencies, which puts a performance overhead on the SQL Server database, because for every SQL dependency, SQL Server database creates a data structure in the server to monitor that data, and that's an extra overhead. So if you have a lot of data to synchronize, maybe it's better to just do DB dependency. DB dependency is our own feature where instead of using a SQL statement and database events, Encache actually polls the database. There's a special table that you create. It's called Encache DB sync, and then you modify your triggers so that you go and update a flag in a row corresponding to this cached item, and then Encache polls this table every so often, let's say every 15 seconds or so by default. And then you can, if it finds any rows that have been changed, it invalidates the corresponding cached items from the cache. So both of these, and of course DB dependency can work on any database. It's not just SQL Server Oracle, but also if you have a DB2 or MySQL or other databases. So with the combination of these features allows you to really feel confident that your cache will be always synchronized with the database, and that you can cache pretty much any data. There's a third way, which is a CLR stored procedure, so that you can actually implement a CLR stored procedure. From there you can make an Encache call, so that you call the stored procedure from the database trigger. Let's say you have a customer table and you have an update trigger or a delete trigger, or even an add trigger. In a case of CLR procedure, you can also add new data. So that CLR procedure gets called by the trigger, and the CLR procedure makes Encache calls. And that way you're having the database adding the data or updating the data back into the cache. So those three different ways allow Encache to be synchronized with the database. And this is a really powerful reason for using Encache over Redis, because Redis forces you to only use expirations, which is not sufficient. It really makes you vulnerable, or it forces you to cache read-only data. You can also synchronize the cache with non-relational database. So if you have a legacy database mainframe, you can have a custom dependency, which is your code that runs on the cache server, and every so often Encache calls your code to go and monitor your data source. And so you can maybe make web method calls or do other things to go and monitor the custom data source, and that way you can synchronize the cached item with data changes in that custom data source. So the synchronization of the database is a very powerful reason why you should use Encache over Redis, because now you can cache practically all data, whereas in case of Redis you'll be forced to cache data that's either read-only or where you can very confidently make guesses about the expirations. Okay. Let me go. Reason number 2. Okay, now that let's say you've started to use synchronization with the database feature, and now you can cache practically a lot of data. So the more data you cache, the more the cache starts to look like a database. And then if you only have the option of fetching data based on keys, which is what Redis does, then that's very limiting. So you need to be able to do other things. So you need to be able to find data intelligently. Encache gives you a number of ways in which you can group data and find data based on either object attributes or based on groups and subgroups, or you can assign tags, name tags. So all of those are different ways that you can get collections of data back. For example, if you were to issue a SQL query, let me show you that. Let's say I go to a SQL query here. So I want to go and find, let's say, all customers where customer.city is New York. So I will issue a SQL statement. I'll say select customers, my complete namespace customer where this.city is question mark, and in the value that I'm going to specify New York as the value. And when I issue that query, I will get a collection of those customer objects back that match this criteria. So this is now looking a lot like a database. So what this means is that you can actually start to cache data. You can cache entire data sets, especially lookup tables or other reference data, where your application was used to issuing SQL queries against those in the database, and the same type of SQL queries you can issue against Encache. The only limitation is that you can't do joins in case of Encache, but a lot of these you don't need to really do the joins. But so SQL searching makes the cache very friendly to really search and find the data that you're looking for. Grouping and subgrouping. Let me show you the example of grouping. So for example, here you can add a bunch of objects and you can add them all so you're adding them as a group. So this is the key, the value, here's the group name, here's the subgroup name. And then you can later on say, give me everything that belongs to the electronics group. This gives you a collection back, and you can iterate over the collection to get your stuff. You can also fetch the keys based on the group. You can do other things based on the group also. So groups and tags work in similar fashion. Name tags are also the same as tags, except it's a key value concept. So let's say if you're caching free-form text and you really want to get some of the metadata of the text indexed, so you can use key value concept with the name tags, and that way once whatever groups, tags, and name tags you have, then you can include those in SQL queries. You can also issue link queries. If you're more comfortable with link, you can issue link queries. So in case of link, for example, let's say here's your Encache. So you would do an Encache query with a product object. It gives you an iQueryable interface, and then you can issue a link query just like you would against any object collection, and you're actually searching the cache. So when you run this query, when you execute this query, it is actually going to the caching tier and searching your objects. So the interface available to you is very, very simple in a very friendly fashion, but behind the scenes it is actually caching or searching the entire cache cluster. So reason number 2 is that you can search the cache, you can group data through groups and subgroups, tags and name tags, and it makes finding data in a friendly fashion. possible, which is something that none of these features exist in Redis. Data indexing is another aspect of this, that when you are going to search based on these attributes, then it's imperative, it's really important that the cache indexes, it creates indices on those attributes. Otherwise, it's an extremely slow process to find those things. So Ncache allows you to create data indexing. For example, every group and subgroup tags, name tags are automatically indexed, but you can also create indices on your objects. So you could, for example, create an index on your customer object on the city attribute. So the city attribute, because you know that you're going to search on the city attribute, you say, I want to index that attribute. And that way, Ncache will index it. Okay, so reason number 3 is that with Ncache, you can actually write server-side code. So what is that server-side code, and why is that so important? Let's look at that. It is read-through, write-through, write-behind, and cache loader. So read-through is essentially your code that you implement, and it runs on the cache server. So actually, let me show you what a read-through looks like. So for example, you implement an iReadThrough provider interface. This interface has 3 methods. There's an init method, which gets called when the cache starts, and its purpose is to connect your read-through handler to your data source. And there's a method called dispose that gets called when the cache is stopped, and that way you can disconnect from your data source. And there's a load from source method, which passes you a key, and it expects an output of a cache item, a provider cache item object. So now you can use the key to determine which object it is that you need to fetch from your database. So the key, as I said, could be customer ID 1000. So it tells you that the object type is customer, the key is customer ID, and the value is 1000. So if you use formats like that, then you can, based on that, you can go ahead and come up with your data access code. And this read-through handler actually runs on the cache servers. So you actually deploy this code on all the cache servers. In case of Ncache, it's pretty seamless. You can do that through an Ncache manager tool. So you deploy that read-through handler to the cache servers, and that read-through handler gets called by the cache. Let's say your application does a cache.get, and that item is not in the cache. Ncache calls your read-through handler. Your read-through handler goes to your database, fetches that item, gives it back to Ncache. Ncache puts it in the cache and then gives it back to the application. So the application feels like the data is always in the cache. So even if it's not in the cache has the ability to now go and get the data from your database. That's the first benefit of read-through. The second benefit of read-through is that when the expirations happen, let's say you had an absolute expiration. You said expire this item 5 minutes from now or 2 hours from now. At that time, instead of removing that item from the cache, you can tell Ncache to reload that item automatically by calling the read-through handler. And reloading means that that item is never removed from the cache. It's only updated. And this is really important because a lot of the reference lookup tables, you have a lot of transactions just reading that data. And if that data is removed even for a brief period of time, a lot of transactions against the database will be created to fetch that data simultaneously. So if you could just update it in the cache, then it's much better. So that's one use case. The second use case is with database synchronization. So when a database synchronization happens and that item is being removed, instead of removing it, why not reload it from the database? And that's what Ncache will, you can configure Ncache so that when database synchronization kicks in, so that Ncache will, instead of removing that item from the cache, it'll call your read-through handler to go and reload a new copy of it. Again, in the same way as expiration, that item never never removed. It never gets removed from the cache. So read-through is a really powerful feature. Another benefit of read-through is that it simplifies your application because you're moving more and more of your persistence code in the caching tier. And if you have multiple applications that are accessing the same data, all they have to do is do a cache.get. A cache.get is a very simple call than doing a proper ADO.NET type of coding. So read-through simplifies your application code. It also makes sure that cache always has the data. It does automatic reload on expirations and database synchronizations. The next feature is write-through. Write-through works just like read-through, except it's for updating. Let me show you what write-through looks like. So this was read-through. Let me just go to write-through. So you implement a write-through handler. Again, you have an init method, you have a dispose method, just like read-through. But now you have a write to data source method, and you have a bulk write to data source method. So this is something that is different from read-through. So in case of write-through, you get the object and the operation also. And this operation could be an add, it could be an update, or it could be a delete, right? Because you could do a cache.add, cache.insert, cache.delete, and all of that will result in a write-through call being made. And this can now go and update the data in the database. Similarly, if you do bulk update, then a bulk update to the database can also be done. So the write-through has also the same benefits as read-through, that it can simplify the application because it's moving more and more of the persistence code into the caching tier. But there's also a write behind feature that is a variation of write-through, where the write behind is basically you update the cache, and the cache then updates your data source asynchronously. Basically, it updates it later. So your application does not have to wait. Write behind really speeds up your application because the database updates are not as fast as cache updates. So you can use a write through with a write behind feature, and the cache gets updated immediately. Your application goes back and does its thing, and then the write through is called in a write behind fashion, and it goes and updates the database. And of course, if the database update fails, then the application is notified. So anytime you have a queue being created, there's a risk that what if that server goes down, that queue will be lost. Well, in case of Encache, the write behind queue is also replicated to more than one server. And that way, if any cache server goes down, your write behind queue is not lost. So that's how Encache ensures high availability. So write through and write behind are very powerful features. They simplify the application code, and also in case of write behind, they speed up the application because you don't have to wait for the database to be updated. The third feature is cache loader. There's a lot of data that you would prefer to preload in the cache so that your applications don't have to go to the database. If you don't have a cache loader feature, now you have to write that code. Not only that you have to write that code, you also have to run it somewhere as a process. It's the running as a process that really becomes more complicated. So in case of a cache loader, you just register your cache loader. You implement a cache loader interface. You register your code with Encache. Encache calls your code whenever the cache is started, and that way you can make sure that the cache is always preloaded with that much data. So these three features: read through, write behind, and cache loader. These are very, very powerful features that only Encache has. Redis does not have any such features. So in case of Redis, you lose all this capability if that Encache provides otherwise. Reason number 4 is client cache. Client cache is a very powerful feature. It's a local cache that sits at your application server box, but it's not isolated cache. It's local to your application. It can even be in proc. So this client cache could be objects kept as on your heap. And in case of Encache, if you choose the in proc option, then Encache keeps the data in object form, not in a serialized form in the client cache. In the clustered cache, it keeps it in a serialized form, but in the client cache, it keeps it in an object form. Why? So every time you fetch it, you don't have to deserialize it into an object. So it speeds up the fetches or the gets a lot more. A client cache is a very, very powerful feature. It's a cache on top of a cache. So one of the things that you lose when you move from a standalone in-proc cache to a distributed cache is that in a distributed cache, the cache is keeping the data in a separate process, even on a separate server, and there's an inter-process communication going on, there's a serialization and deserialization going on, and that slows down your performance. So compared to an in-proc object form cache, a distributed cache is at least 10 times slower. So with a client cache, you get the best of both worlds, because if you don't have the client cache, if you just had a standalone isolated cache, then there's a lot of other issues about size of the cache. What if that process goes down, then you lose the cache, and how do you keep the cache synchronized with changes across multiple servers? All of those issues are addressed by Encache in its client cache. So you get the benefit of that standalone in-proc cache, but you're connected to the caching cluster. So whatever is kept in this client cache is also in the clustered cache, and if any other client updates it here, the caching tier notifies the client cache so that it can go and update itself immediately. So that's how you make sure, or you rest assured that your client cache will always be synchronized with the caching tier, which is then synchronized with the database. So a client cache, in case of Encache, a client cache is something that just plugs in without any extra programming. You make the API calls as if you're talking to the caching tier, and the client cache just plugs into a configuration change. And a client cache gives you 10 times faster performance. This is a feature that Redis does not have. So despite all the performance claims that Redis has, they are a fast product, but so is Encache. So Encache is head-to-head in performance with Redis without the client cache, but when you turn on the client cache, Encache is 10 times faster. So that's the real benefit of using a client cache. So this is reason number 4 for using Encache over Redis. Reason number 5 is that Encache provides a multi-data center support. These days, if you have a high traffic application, the chances are very high that you either are already running that in multiple data centers, either for disaster recovery, DR, or for 2 active data centers for load balancing, or a combination of DR and load balancing, or maybe it's geographical load balancing. So you may have a data center in London and New York, or Tokyo or something like that, to cater for regional traffic. Whenever you have multiple data centers, that your databases provide replication, because without that you wouldn't be able to have multiple data centers, because your data is the same across multiple data centers. If the data were not the same, then it's a separate, there's no problem. But in a lot of the cases, the data is the same. And not only that, but you want to be able to offload some of the traffic from one data center to the other in a seamless fashion. So if you have the database replicating across data centers, why not the cache? Redis does not provide any such features. Encache provides very powerful features. So in case of Encache, you have every data center is going to have its own cache cluster, but there's a bridge topology in between. That bridge is essentially connects the cache clusters in each data center so that you can asynchronously replicate. So you can have an active passive bridge where this is an active data center, this is passive. You can also have an active bridge, and we're also releasing more than 2 data center active or active passive configurations, where you can have, let's say, 3 or 4 data centers, and the cache will be replicated to all of them in either an active fashion or an active passive fashion. In an active, because the updates are being done or the replication is being done asynchronously, there's a potential for conflict that the same item was updated in both data centers. So Encache provides 2 different mechanisms for handling that conflict resolution. One is called last update wins, where whichever item was updated last gets applied to both places. So let's say you update an item here, another user updates the item here. Both of them now start to propagate to the other cache. So when they come to the bridge realizes that they've been updated in both places. So then it checks the timestamp, and whichever timestamp was the last, it applies that update to the other location, and it discards the update that was made by the other location. So that's how the active last update wins conflict resolution happens. If that's not sufficient for you, then you can implement a conflict resolution handler. That's your code. So the bridge will actually, in case of a conflict, call your code, pass both copies of the objects, so you can do content-based analysis. And then based on that analysis, you can then determine which object is more appropriate to be updated, to be applied to both the data centers. The same rule applies if you have even more than 2 data centers. So a multi-data center support is a very powerful feature. Encache gives you out of the box. Once you buy Encache, it's all there. Redis does not. And if you either plan to have multiple data centers, or even if you just want to have the flexibility, even if you don't have multiple data centers today, but you want to have the flexibility of being able to go to multiple data centers, would you buy a database today that does not support replication? You probably wouldn't, even if you only have one data center. So why go with a cache that does not support across the WAN replication? So this is a very powerful feature of Encache. So up until now, we've talked about mainly features that a good distributed cache must have, and Encache, shines. It wins hands down over Redis. Redis is a very basic, simple cache. Reason number 6 is probably one of the most important reasons for you, which is platform and technology. If you have a .NET application, you would prefer to have the complete .NET stack. I'm sure you would not want to mix .NET with Java or Windows with Linux. In most cases, in some cases, you may, but in most cases, people who are developing .NET applications prefer to use Windows platform and prefer to have their entire stack to be .NET if possible. Well, Redis is not a .NET product. It is a Linux-based product that was developed in C++. Let me show you. Here's the Redis Labs website, which is the company that makes Redis. If you go to the download page, you'll see that they don't even give you a Windows option. So that, despite the fact that Microsoft has picked them for Azure, they have absolutely no intention of supporting Windows. So as far as Redis Labs is concerned, Redis is only for Linux. Microsoft Open Technology Group has ported Redis onto Windows. So there's a Windows version of Redis available. It's open source and is unsupported. But it's buggy and unstable. And the proof is in the pudding that Microsoft itself doesn't use it in Azure. So the Redis that you use in Azure is actually a Linux-based Redis and not the Windows-based. So if you want to incorporate Redis into your application stack, you're going to mix oil with water. Whereas in case of Encache, everything is native .NET. You have Windows, you have 100% .NET. Encache was developed in C#. It is certified for Windows Server 2012 R2, and every time a new version of operating system comes, it is certified for that. We're going to be pretty soon launching the ASP.NET Core support. So we have a .NET client officially. We also have a Java client officially. So I think if you use Encache, and again, Encache is also open source. So if you don't have the money, go with the open source version of Encache. But if your project is important, then go with the enterprise version, which gives you more features and support both. But I would highly recommend that you use Encache if you have a .NET application for both the .NET and Windows combination. The second benefit that Encache gives you is if you're not in the cloud, let's say you haven't decided to move to the cloud, you are hosting your own application, so it's on premises essentially. So it's in your own data center. Well, Redis that is available by Microsoft is in Azure only. So anything that is on premises, so there's a Redis that is available on premises by Redis Labs, but that's only Linux. And the only on premises on Windows is the open source, the one that comes with no support, and the one that's buggy and unstable, and the one that is so buggy that Microsoft itself doesn't use it in Azure. Whereas in case of Encache, you can either continue to use the open source, which is free, which is unsupported, of course, if you don't have the money, but it's all native .NET, or if you have a project that's important for your business, then buy the enterprise edition that has more features and comes with support, and it's a perpetual license. It's pretty affordable, to own it. And we also give you 24/7 support in case that's important for you. So it's fully supported in an on-premises. Most of our customers that are high-end customers are still using Encache in an on-premises situation. And Encache has been in the market for more than 10 years, so it's a really, really stable product. As far as the cloud support, Redis gives you a service model in the cloud, which is Microsoft has implemented a Redis service. Well, Redis service means that you don't have access to the cache servers. It's a black box for you. There's no server-side code. So all that the read-through, write-through, right behind, the cache loader, the custom dependency, and a bunch of other stuff, you cannot do with Redis. You only have the basic client API. And as I said, on Azure, Microsoft gives you the Redis as a service. And Cache, we've intentionally picked a VM model because we want the cache to be close to your application, and we want you to have total control on the cache. This is something that's very important because we have many years of experience, and we know our customers are very sensitive. Even a small, let's say if you use the Redis as a service and you have to make one extra hop to get to the cache every time, that just kills the whole purpose of having a cache. Whereas in case of Ncache, you can have it as part of the VM. You can have the client cache. It's really embedded within your application deployment, so you can do all the server-side code. Ncache also runs on Azure. It runs on Amazon, AWS, and also other leading cloud platforms in BYOL model. So you basically get your VM. Actually, you have the Ncache in the marketplace. You get an Ncache VM, and you buy the license from us, and you start to use Ncache. So very different approaches, but this is the approach that is intended if your application is really important and you want to control the application, every aspect of it, and not have to rely on somebody else managing a chunk of your application level infrastructure. It's one thing to manage VMs and the hardware underneath, but as you start to go more and more upward, then you lose that control. And of course, in case of caching, in case of Ncache, it's not only that control, but also a lot of features that you would lose if you went with the service model. So reason number 6 is platform technology. For .NET applications, Ncache is a much more suitable option than Redis. I'm not saying Redis is a bad option, but I think for .NET applications, Ncache is a much more superior option than Redis. Let me just give you a brief history of Ncache. Ncache has been around since the middle of 2005. So that's 11 years. Ncache has been in the market. It's the oldest .NET cache in the market. 2015, January, we became open source. So we are now Apache 2.0 license. Our enterprise edition is built on top of our open source. So the open source is a stable, reliable version. It has a lot of features. Of course, enterprise has more features, but open source is a very usable product. The basic thing is, if you don't have the money, go with open source. If your business application is important and you have the budget, go with the enterprise edition. It comes with support and also gives you more features. We have hundreds of customers, pretty much all in every industry possible that needs caching. So we've got financial industry customers, we have Walmart, other retail industry, we've got airlines, we've got insurance industry, car, automobile, just across all industries. So that's the end of my talk. Please go ahead and download the enterprise edition of Ncache. Let me actually take you to our website. So essentially go to the download page, and I would highly recommend that you download the enterprise edition. Even if you end up going to using open source edition, download the enterprise edition. It's a fully working 60-day trial, which we can easily extend. And play with it. If you want to go ahead and download the open source, go ahead and download the open source. You can also go to GitHub, and you can see Ncache at the GitHub. So overall, it is. And please contact us if you want to us to do a personalized demo. Maybe talk about your application architecture, answer your questions. Thank you very much for watching this talk.